Good morning, guys. So, I hope you have understood the theory part of the chapter Motion in Straight Line, and that chapter is written in motion one dimension in most of the entrance books. Okay, so don't confuse it. The next chapter is motion in two dimension, written in the NEET books or any of the entrance books, but in your textbook, it is written as motion in plane. Clear? So when you're dealing with that chapter in the perspective of NEET or entrance section, both theory we have completed now, right? So theory as well as problem section, or I can say numericals, are very important. If you see the earlier NEET JE paper, right? NEET JE or IIT papers, when you check, you will see that problem section carried majority of the weightage, whereas the theory was less. But in the case of NEET, this year it flipped. Now this year 2020 NEET year was such that problems was less and theory was majorly covered, right? So but the JE was similar. Okay, the problem was higher and the theory was less. So what we should do, we cannot cannot tell the future, that we cannot say what can type of questions can come in future. So what we will do, you have to give both of the sections important, that is theory should be thorough as well as the problems, right? So till now we completed little bit of theory, not little bit, complete theory and little bit of problems along with it, right? From today class, we will start to do little bit more problem sections, right? So let's move on to the theory, guys. So let's rub it this section, or I could have dragged it, right? Let's drag it like this. Okay, now let's move on to the first problem which I want to cover, which is the 100th question, which you can see. A ball is thrown vertically upwards with a certain velocity. Another ball is released from a height of 60 meters. So two balls are there. One is thrown up, the other is dropped. They meet at a height of 15 meters. Then what is the initial velocity of the first ball? That is, you are asked what is the velocity of the ball which was thrown up. So first of all, as I have told you earlier many times, I believe, or I think only one time right now, that is almost all the motion types of questions in physics in this year or next year, make sure you draw a figure for the questions. Okay, so you are having a ground and you're throwing a ball up with a velocity which you don't know, you have to find. Let's say there is a platform here and another ball is coming downwards. This platform is a height, let's say is a platform, means you are told that is another ball is dropped, right? So I am going to take that as a platform which is at a height of 60 meters from the ground, right? And they are meeting, that both the balls are meeting here, right? And this meeting point is at a distance of 15 meters, right? This much is a figure clear. And this first ball which is dropped, right, so its velocity will be 0. This is the second ball, sorry, this is the second ball, and this is the first ball's velocity. This much clear, right? Now what and all is clear by this figure itself, regarding the first ball, right? This first ball, when it reaches this meeting point, let's say it is P, when it reaches the point P, how much distance it has traveled? It has traveled 15 meters. Clear from the figure, right? Now what's about the second ball? How much distance the second ball has traveled? 60 is the total height. It met the first ball at this height, means the second ball has traveled only this much. That is 60 minus 15, that is 45 meters. Right? So the second ball has traveled only 45 meters. Right, so let's apply second balls with an equation S is equal to ut plus half at square. Right, half at square means t is the time by which both the balls meet. So both the balls are released simultaneously. They are released at the same time, not simultaneously, let's say at the same time. So if both are released, say both are released at 10, both meet each other at 10:05. That means both have traveled for how much time interval? 5. So I am meaning about the both travels, let's say, has traveled t seconds before they met. So we are applying this equation. So for the second ball. So second ball, how much is the distance the second ball has traveled? It has traveled only 45 meter. It is dropped means u is 0, right? Then minus, right? A will be minus g is 10. Let's take it as 10, then it's easy to solve. Then there is t square, right? So it is dropped, right? So s will be negative because displacement is downward, so minus 45. So you will get minus 90 is equal to minus 10 t square, or t is equal to 3 seconds. So 3 seconds after the ball is released, both of the balls are released, they meet. Clear? This much clear, easy, right? So I'm taking this portion very slowly because this is the first question. Then we'll jump. Right, so that means the first ball has also traveled for only 3 seconds. So for ball 1, s is equal to ut plus half gt square. Right, the s, how much it has traveled? 15 meter. U I have to find, in place of t I will write 3 and this minus, right? G is 10 and there is 3 square. So obviously you can find the value of u. Please do the calculation, guys. You will find the value of u as 20 meter per second. That is, the first ball is thrown up with a velocity of 20 meter per second. Calculation side, please do it by yourself. Simple, easy. Right, now let's move on to the next question, which can be seen here. Let's do the 106th question. A ball falls from a height h. After 1 second, another ball falls freely from a point 20 meter below the point from where the first ball falls. Both of them reach the ground at the same time. What is the value of h? That is, both the balls are freely falling. One is released. After that, only 1 second after that, only another ball is released. Right? So I hope you understood. And there is a height difference. First, if one is released at the height h, the other is released at a 20 meter below to it, right? So let's do the problem with the figure again. Let me drag. So what was the question number, guys? I believe it is 106, right? As per the paper I have taken. So let's take for the first ball. It is released, let's say from here, both. So this has reached the ground here. So it is traveling a height h. The arc will deal with the second ball. If this is the height, it is told that the second ball, okay, let's I took another color. Okay, second ball is at the height below 20 meter, right? Below 20 meter, the another ball is dropped from here, right? So that means how much is the distance it is going to travel? It is going to travel only h minus 20 meter. Right, the second ball. This is for the first ball. This is for the second ball. Both are freely dropped, means the initial velocity is 0. Simple, clear. Now let me tell, that means if the first ball is taking t time to reach the ground, right? If first ball is taking t time for the reaching of the ball, that is, see, one is released at, let's say, 10 a.m. The other is released at 10:01 a.m. right, and both are reaching at 10:05, means one, right? You are told that the second ball is released 1 minute late or 1 second late, right? So I'm taking in the minutes form because it is easy to understand with a number. So I hope you understood. So it reached at the time 10:05, means if the first ball took only how much minutes? 5 minutes. Whereas the second ball took how many minutes? 4 minutes, right? So 1 minute less. Similarly, let's do with this one. First ball took t seconds to reach the ground, means the second ball, which is released after 1 second, will take how much seconds? T minus 1 second to reach the ground, right? Because both of them are reaching at the same time, right? Now let's move on with the equation, guys. That means for the first ball I will write dropped, right? So h is equal to half gt square. So this is actually minus, so minus g, so I can write minus minus, so it becomes plus, right? Whereas the next case, second ball, h minus 20 is equal to half g t minus 1 whole square, right? In place of h, I can write this equation, right? So in place of h, I'm going to write it as gt square by 2 minus 20 is equal to half g t squared minus 2t plus 1 a minus b whole square formula, right? After solving this, I'm not going to do it, guys. You will get t, right? T, okay, is equal to 2.5 second. That is, the first ball is going to travel how many? 2.5 seconds, whereas the second ball will travel how many second only? 1.5 second only, right? So I can find the height of the first ball, right? When will the first, what was the height of the first ball? H is equal to half gt square. Substitute this value, you will get the height value as 31.2 meter. Clear? So the first ball is at a height of 31.2 meter from the ground. Clear? Easy, right? Now we move on to the next question, guys. Oh, sorry. Let's move on with the 107th question. It is very easy. A body is fired vertically upwards. At half the maximum height, the velocity of the body is 10 meter per second. The maximum height reached by the body is. It is very easy. Again, we have to draw the figure. Okay. So that means you are told you are having two voyages. Half, right? You're throwing a body from below, so half distance, let's say this height is height, this height is height, so the total height is 2h. So this is half distance, right? At half distance, its velocity is said to be 10 meter per second, right? When you throw an object upward, so, and this is a full voyage from here to here, so at maximum height the velocity would have become 0, right? So easy, right? You just consider this half, so this becomes initial velocity, this becomes the half final velocity in the case of this much height. So v squared minus u squared is equal to 2gh, right? You're throwing up, right? Only g is minus, right? Displacement is positive, velocity is positive, right? Now this is 0, so you get minus u squared, write it as 10 whole squared is equal to 2 minus 2 is 10, sorry, g is 10 and there is h, right? So you will get h is equal to 5 meter, right? So this is 5 meter, right? Then this will be also 5 meter. So what is the total height? It is 5 plus 5, that is 10 meter, right? So the ball will reach to the maximum height of 10 meter. Clear? Very easy question, not that much complicated. We'll go for the next question. Okay, again I have to drag on. So let's take 108th question. What is the question? The velocity of the bullet reduces by 1/20th of its initial velocity after passing through one plank or a plank, right? The maximum number of planks it can cross, right? How many planks has to be kept so that the velocity of the bullet goes to 0? That is the meaning, right? Now let's solve that one. Ouch, I dragged in the wrong way. So I hope you understood the question. So you're asked, see, let's say, okay, u is the initial velocity of the bullet, right? And x is the thickness of one plank, okay? And like that, let's say there are n number of planks, means the total displacement the bullet has to travel so that its velocity becomes 0 is nx, right? See, this is one plank, another plank, like that. I'm just drawing the top view, guys, right? So like that, when the bullet is coming, let's say there are n number of planks, means each plank is having thickness x, means what will be the total thickness of the entire system? It will be nx, right? So by reaching this nth number of plank, the velocity is becoming 0. Clear? So the initial velocity u, final velocity v, which is equal to 0 in this condition, and the total displacement in this condition is nx, right? So can't I write v squared minus u squared is equal to 2a, the acceleration of the bullet, and distance traveled is nx, and v squared in the case is 0 because now the bullet is having 0th velocity. So minus u squared, right, is equal to, or I can say plus u squared is equal to minus 2a nx, right? Let's keep that as first equation, right? Now I'm just going to consider single plank, right? What happens when a bullet is traveling through single planks? This is a single plank, right? So initially the velocity was u, right? And once it travels by one plank, its velocity reduces by minus, or it reduces by u by 20, means the rest of the velocity will be only, right, once it travels by one plank, initial velocity, if it is u, passing through one plank, now its velocity would have become 19 u by 20, 1 u by 20 when it is reduced, right? U minus u by 20 is 20 u minus u by 20, that is 19 u by 20. Clear? Easy, right? So that is very easy calculation. I don't think I have to write it, right? So now okay, so 19 u by 20, why did I remove that one, right? 19 u by 20 is the final velocity with regarding to one plank. Initial velocity is u, and how much is the displacement which is covered by the bullet? It is x, right? That is the thickness of one bullet, so the one plank, right? So in the case of the one plank case, I can write v squared minus u squared is equal to 2as. V becomes what? 19 u by 20 whole squared minus u squared is equal to 2ax. Right, now this is something you can calculate, right? I'm straight away going to write the values, guys, right? You will get around u squared is equal to 400 by 39 into minus 2ax, because there is a minus here, right? Clear? You will get a u square value as this much. So you have u square value in two equations, 1 and 2. You can equate both this equation, and you can find xx cancels, ai cancels, and you can straight away find the n's value, and the n will be found as, I believe, 10.25, right? That means you are getting a decimal value. So that means the planks are more than 10, right? Just more than 10. So you will be given options like this: 9, let's say 6, 11, D is 12. So which option you have to take? You have to take 11, right? So this just greater than 10, like that. I hope this much is clear, right? Move on to the next question, guys. This is 110th question, as you can see in the paper, or the board, sorry. A ball is dropped from the top of a building which is 100 meter high. At the same instant, another ball is thrown upward with a velocity of 40 meters per second from the bottom of the building. The two balls will meet after. This is a question which is also mentioned in your NCERT textbook, textbook questions, right? Okay, guys. Maximum questions I am trying to do outside the NCERT questions, because I want you guys to do the NCERT questions by yourself. You can take the help of any medium you want, right? And if possible, I will try to send it as a PDF file, the solutions of it, so that once you understand the entire theory sections, it is very easy to solve the NCERT problems. Okay, so let's move on to the 110th question. So how to solve that, right? So what has been told? The ball is dropped, right? What was the question again? Okay, ball is dropped, right, from the top of a building which is 110 meters. At the same time, another ball is thrown up also, right? So one is initial velocity of the first ball is 0 meter per second, whereas the second one is having a velocity 40 meter per second, right? So let's draw the picture, guys. right? So let's see, this is my first ball, right? So it is dropped, right? And another ball is thrown up, right? Now you are asked when they will be meeting. Now there are some scenarios you guys have to understand which has not been taught during the theory class. That is, both are in opposite direction, right? So I have taught you about the relative velocity, so not like this, okay? Relative velocity, right? So one, if this dropped, means its velocity, initial velocity is 0. Thrown up object is having an initial velocity of 40 meter per second, right? So up means this is positive, this is negative, right? So the relative velocity between these two guys, right? Or I can say of the second ball with respect to the first ball, right? I can say it is both. If they are, I told you, if there are two objects, they are moving in opposite direction, relative velocity is their sum, right? So it is v1 plus v2 means first ball plus second ball's velocity. Very easy, right? 0 plus 40, it is 40 meter per second is the relative velocity between these two balls. Very easy. That's why I told you during the class, don't need to take the direction in these cases, right? So the relative velocity between the two balls is 40 meter per second. What is the relative acceleration between these two guys? This first ball which is dropped is also having acceleration downwards, so minus g, right? Now the second ball is also having the up direction it is moving, right? Then also its relative, sorry, its acceleration is downward, right? The second ball is having the downward acceleration, first ball is also having downward acceleration. And I have told you, just like the velocity case, you can also take the relative acceleration. So both the acceleration same direction means relative acceleration is difference of these guys. So minus g minus minus g. So the acceleration is 0. So relative acceleration between these two balls is 0. Relative velocity between these two balls is 40 meter per second. Right? Clear? Now let's say the balls are meeting after t seconds. They are released at the same time, right? So after t seconds they are meeting. And the distance traveled by the balls, let's say, is s, right? So I hope you understood. Let's s be the distance traveled by the balls and t be the time after which, or t is the time when they are meeting after t seconds, right? So okay, I can write s is equal to ut plus half at square, right? Now a relative acceleration is 0, so this term goes 0. What is the relative velocity or relative distance between these two guys? Or I can say initially, right, it is 100 meter, one is dropped, the other is from bottom, means the relative displacement is 100, right? And what is for this u, the relative velocity? 40. Let's say they are meeting after t, right? So I can just directly find the time after which they are meeting is 2.5 seconds. So after 2.5 seconds, that is, if this is ball dropped, this is the ball thrown, right? If they are both released at 1 o'clock, so after 1 o'clock to after 2.5 seconds of the 1 o'clock, they will meet each other. Both of them are released at 1 o'clock. Okay, one is dropped, one is thrown up. Clear? Easy, right? Now let's move on to the next question. Okay, I want to do the 111th question. You are told there is a 130 meter long train is moving up direction with speed 72 km per hour. Another train of 120 meter long is moving in down direction with speed of 108 km per hour. The time in which the second train crosses the first train will be, guys, up and down. I'm going to draw it as in this direction because it is much easier if I draw in this way. Okay, let's drag it. So this is my up and this is my down. Okay, because it is very easy to understand by this drawing. Okay, up and down, I hope you understood. So let's first draw let's understand what is the first train. It is having a length of 130 meter right? And its velocity v1, let's say, is 72 kilometer per hour, right? Now let's say L2, there is the length of the second train is 120 meter, and its velocity v2 is 108 kilometer per hour, right? So this L1 train is moving up in this direction with a velocity 72 kilometer per hour, and the other train of 120 meter, this is 108 kilometer per hour velocity. This is v1, this is v2. Again, when two velocities or two objects are moving in opposite direction, then relative velocity is sum of them, that is v1 plus v2, that is 108 plus 72 will be 180 kilometer per hour, right? So remember, this velocity is in kilometer per hour, but our distances or length is in meter. So I'm going to convert kilometer per hour. How can I convert kilometer per hour to meter per second? Just multiply it with 5 by 18, right? This you would have learned in your 9th class. So you'll get 50 meter per second is the relative velocity between these two trains. Easy, right? Now let's draw. So this is my length L1 train, right? This is L1, this is my L2 train, right? Now how much distance has to be the second train has to travel so that it can cross the first train? See, first this L2 train has to reach this much length, right? So that means how much travel it has to be done, this much length has to be covered, right? So that is L1. So L2 for train, this is the second train, right? The second train first has to travel L1 distance, right? Now the second train has reached here, right? Now it has to cross over, means this has to reach here, right? The second train has to reach here. That means, see, I hope you understood the scenario. I can draw if you want again. Let's see, I will draw it again, guys. Say this is my first train, which is having length L1. This is my first train, this is my second train, right? So if the second train wants to cross over the first train, so first second train has to reach here, right? So that means the second train must have covered this much length, right? How much length? L1 length, right? Now the second train has reached here. Now it has to cross over, means its scenario should be like this. The second train should be like this, right? So that means how much it has to cover? That means it has to cover its own length outwards, right? This much length it has to cover so that it reaches this point. So the total length which is covered by the second train is L1 plus L2. Then only it can cross over the first train. First it has to cover the entire length of it has to travel the entire length of the first train. Then this engine part, let's say this is the engine part, has to reach this point, right? So that means it has to cover its own length. So that means the distance which is to be traveled by the second train is L1 plus L2. Clear, right? So the displacement or the length moved by the relative distance between the two trains is L1 plus L2, that is 130 plus 120, it is 250 meter, right? And what is the relative velocity? It is 50 meter per second. So what is the time taken to cross over? Relative distance, that is 250 meter, by relative time, so velocity, that is 50. So in 5 seconds the second train can cross over the first train. Clear? Easy. I hope this much is clear. See guys, I have covered almost good questions, right? During the live class we will do a lot of other questions. By this entire week will cover most of the important questions from the chapter motion in one dimensions. Okay.